We're moving on to a new chapter today, and we're going to look at strange functions. We're going to look at functions that can be cut into different pieces, and functions that you can't draw unless you can't draw in a continuous pencil movement. You have to lift your pencil up, and so a lot of funny things are going to happen. Before we do that, I want you to be really familiar with some very basic functions. We refer to them as parent functions. So today's pretty simple. If you look at this first page, you need to graph this function without a calculator, meaning you don't get to graph it on your calculator. If you need a calculator to do the math, that's fine. But you're just not allowed to graph it. So the function is f of x equals x, and we need to fill out this table of values and graph those points to figure out what the function looks like. So what happens when we plug -3 into that function? We take -3 and we stick it there, and we get out -3. So we graph the point -3, -3. What happens when I plug in -2? -2, oh, I'm seeing a pattern. -1, 0, 1, 2, and 3. So I connect the dots. It's just a line at a 45-degree angle. Well, then we have to fill out all the answers to those questions. So remind me what domain means. The x's. So I'm going to draw a line, a vertical line through the x-axis, and I'm going to use this line to help me figure out what the domain is. Are there any x values, so any of these numbers, that if I draw the line, that line will miss the graph? So at -2, does the line hit the graph somewhere? Yeah, down at -2. What about over here at 4? Does it hit the graph? Okay, what about over here at 25? It's still going to hit the graph somewhere way above the paper. Are there any x's that don't hit the graph? They all hit the graph, so the domain would be all real numbers. So all real numbers. What does range mean? The y values. So I'm going to take this same line, but I want to rotate it 90 degrees, so now it hits the y-axis. Are there any y values that miss the graph? What about down here at -8? It's going to hit the graph over here in the corner, right? Because that line goes forever and the graph goes forever. So the range is also all real numbers. Okay, increasing and decreasing. Remember that increasing and decreasing are measured as you travel from the left side of the graph to the right side of the graph. Because you could look at this and say, oh, it's going up and it's going down. But it depends on which direction you're facing. So we always look at it the same way we read a book. So where is this graph going up? You could say -infinity to infinity, or all real numbers. It's always going up. So all real numbers. Where is the graph going down? It never goes down. It's always going up. Now, again, it depends on what direction you're facing, but we always face this direction. And if we look to the right side of the graph, it's going up everywhere. So this would be never. Okay? What does positive mean? Meaning when it's above the x-axis. Is this graph ever above the x-axis? Okay, when does that happen? It is positive at 1. 0.1, can you go smaller than that? 0.001. What about at 0? Is the graph above the x-axis at 0? No, it's on the x-axis. So everything from here over creates the graph above the x-axis. 0 to infinity, right? But is 0 part of the set? Is the graph above the x-axis at 0? No, so we put a parenthesis. And infinity always gets a parenthesis. Okay? When is the graph negative? So we always put the little number first. Negative infinity until, so every x from negative infinity until 0. And is 0, does 0 create a negative number? No. So it gets a parenthesis. Bracket is only if it does get counted. But in this case, 0 does not get counted. Yeah. Okay. Max or min? Does this have a max or a min? No. The maximum is infinity and the minimum is negative infinity. Yes. Only if you want credit. So this has no max or min. What are the zeros of this graph? 0. It only hits the x-axis in one place at 0. And what is the y-intercept? 0. Okay, now these last two are ways to describe what direction the graph is traveling as we go to the right and what direction the graph is traveling as we go to the left. None. There is no largest number and there is no smallest number. So, as x approaches negative infinity, so if we look at the graph and we follow x to the left, what direction is the graph traveling? Towards negative infinity. Okay? And as x approaches infinity, which is to the right, the graph is going up towards infinity. Okay? All right. Let's do this one together. Now, I highly recommend if you're going to plug negative numbers into a function that you put parentheses around it. So for this first one, I'm going to plug in negative 3 squared. And I get negative 9. But we know that negative 3 times negative 3 is actually positive 9. So why did the calculator mess it up? Well, the calculator is actually smart. It was me that was dumb. The calculator follows order of operations. So if you look at the order of operations list, exponents are higher on the list than subtraction. So the calculator looks at this and says, oh, there's a subtraction and there's an exponent. So which one should I do first? I'm going to do the exponent first and then the subtraction. But what I want is this. Negative 3 squared, not the opposite of 3 squared. So whenever you're plugging negatives into a function, always use parentheses. And that way we're going to end up with 9. So negative 3, 9. Can I graph that? It doesn't fit on the graph, so no. When I plug in negative 2, what will I get? 4, and then 1, 0, 1, 4, 9. So I can graph some of those. This one, and this one, and this one. That one, and that one. And I get a parabola that looks like this. Now I answer all the same questions that I answered before. What is the domain of this function? Well, I draw a vertical line. Does that vertical line ever miss the graph? No, it's going to hit the graph somewhere, no matter where I put the line. So the answer to the domain would be all real numbers. Okay. For the range, I'm going to rotate this. Will this line always hit the graph? Oops. It hits it up here, right, and up forever. But what about down there? So what y values are included on the graph? Everything from 0 to infinity. Now this is a little bit tricky. 0 to infinity. Does the line hit the graph when y equals 0? Yes. So 0 gets a bracket. Because 0 does count. It is part of the answer. Is infinity part of the answer? No. We can never get to infinity. Okay? So when is this graph going up? So if we go back to here and we travel from left to right, so essentially you're driving a car on that graph. Is the graph going up or down right now? Down, down. Now it's going perfectly flat, and then it starts going up. So when on the x-axis is the car flat? At 0, and how long does it increase after that? So increasing is 0 to infinity, and then we have to ask, is the graph going up at 0? No, so 0 gets a parenthesis. 0 is not part of the answer. If you're driving in that car, you're going down the hill, down the hill, down the hill, and then at 0 you're flat. So is the car increasing its altitude at 0? No. As soon as it gets past 0, then it starts going up the hill again. So parenthesis, parenthesis. When is the car going down the hill? Negative infinity to 0. And is the car going down at 0? No. So it gets a parenthesis. Okay. Where is the graph positive? So positive means above the x-axis. When is that parabola above the x-axis? Everywhere but 0. So there are two ways to write this. You could either say negative infinity to 0, union with 0 to infinity, but essentially all I did was got rid of one number, right? So you can say, and this is how I would prefer to do it, all real numbers, but x is not allowed to be 0. If you're only throwing out one number or two numbers or three numbers, you can list them like this. That's when it's positive. That means not equal to. Every real number except 0. That's what it means. There's none on the bottom. Everywhere but 0. So, oh, okay. You understand? Okay, when is this graph negative? And where do you see the graph down here? Nowhere, so it'd be never. Okay. Does this have a maximum? No. Does it have a minimum? Yes. What's the minimum? Y equals 0 is the minimum. Does this have any zeros? X equals 0. And does this have a y-intercept? 0. Okay, and now end behavior. As x goes to negative infinity, which is left, what direction is the graph traveling? Toward... So, if we travel in that direction, the graph is going towards infinity. Well, it says, as x gets smaller, as x gets close to negative infinity, where is the graph? It's up at infinity. So as x approaches positive infinity, which is to the right, the graph is also going to infinity. Okay? Now, what if I had this graph? So in this case, as x approaches in negative infinity, y approaches what? So if that's my graph, As x goes to the left, the graph is going down towards negative infinity. But as x approaches infinity, y is approaching what? Nope. It's getting closer and closer to 0. See how it's leveling off? Right, it'll never get there. But the bigger x gets, the closer x gets to infinity, the closer y gets to infinity. Which is essentially what this is saying. As x gets closer to negative infinity, the y value gets closer to positive infinity. But it'll never get there. It's just approaching that number. Okay, so there's a couple things I want to show you. Go to the next page. For number 3, does everybody know how to do third power on their calculator? So, and remember, when you plug in negatives, you need to put them in parentheses. So parenthesis, negative 3, parenthesis. How do you do third power? Nope. You push this button right here, the caret. Now, some of your calculators will look like this. But if you... I push that button right there. Now, mine actually will raise it up. It just depends on how new your calculator is. The older ones don't put it up high. They just list the caret in there. Then 3, yeah. Yeah, that's the exponent button. Okay? So then you'll be able to graph that. Does everybody know where the square root button is? It's right here above the x squared button. So second x squared, oops. So second x squared. And then I'm going to type in negative 3. And I hit enter. Why doesn't that work? Can you square root a negative number? No. So if we look down here, when I plug negative 3 in, what do I get out? There is no answer, so that doesn't exist. When I plug in negative 2, what do I get out? What is the square root of negative 2? There isn't one. Negative 2 squared is 4, but what times itself is negative 2? Nothing. Okay, what about the square root of negative 1? It would be, these are imaginary numbers, right? The first one would be I root 3, and then I root 2, and I. But how do you graph i's on this graph? You can't. So that doesn't exist, and that doesn't exist, and that doesn't exist. But these will. Some of them will be decimals, but that's okay. So when you graph it, I'm not going to show you what it looks like, but whatever the graph is, there are no graph points on that left side. There just doesn't exist. So that's going to change your domain, and the end behavior. As x goes to negative infinity, what direction is the graph traveling? There isn't a graph, so there's no answer to that. Okay? And then next page. Where do you find the third root button? And if you go into math, so if I push math, number 4 is third root. Did everybody see that? When you get to number 5, the third root button is right here. Math 5 is where you find third root. Okay? And then on number 6, do you know what that symbol's called? It's called the absolute value. Absolute value measures how far a number is from 0. So what is the absolute value of 7? 7. What is the absolute value of negative 6? 6. Oops. Okay. There is an absolute value button on your calculator. If you push math and you go over here to number, so I could do the ABS of, let's say, negative 13. And it tells me, well, the answer is 13. Now, if you have the old version of the calculator, it won't look like this. It will actually say ABS parenthesis negative 13. But it will work the same way. It just doesn't look the same. Okay. Get to work. This is due tomorrow. Good luck.